All right, we're looking at prime factorization and greatest common factors. So the very first thing I want you to do in this chart here, is I want you to find all the factors of 24 and list them here. So just pause the video and do that for me, please. All right, so this would be 1, 2, 3, 4. 4 times 6 is 24. 3 times 8 is 24. 12 times 2 is 24, and obviously 24 times 1 is 24. Okay, so now that we've got that, what I would like you to do is, once again, you're going to pause the video, and you're going to find the prime factorization of each of these factors, and you're going to write them in here. So 3 is obviously the prime factorization. 2 times 2. Okay, so just pause and do the rest. All right, so 2 times 3. 2 times 2 is 4 times 2 is 8. 2 times 2 is 4 times 3. 2 is 4 times 3. So 2 times 2 is 4, 8, and then times 3 is 24. Okay, so now that we have this, I'm challenging you to describe how the prime factorization of each factor is related to the prime factorization of 24. So I just want you to make some sort of generalization from what you see here. So pause the video and just give it a thought. Okay, so we are going to have a look how many 2's are in the prime factorization of 24. So we're just going to have a look here, and there's 3 there. Okay, so how many 3's are there? Okay, there's 1. Does any factor of 24 have more than 3 2's? So that is definitely a no if you have a look there. Why does this make sense? And does this fit with your generalization that you made? So just think about that. Now, if there were more than 3 2's in the factor, then there would be more than 3 2's in 24, right? Because this is your biggest number here. So because 24 equals the factor and another number, right? So 24 times 1, since there are only 3 2's in 24, there cannot be more than that in the factor. So let's see if this holds true. Okay, so let's do the prime factorization of 12. Okay, and 15. So I just want you to do those right now as well. All right, so the prime factorization, 2 times 2 times 3, right? We have it up here, easy to find. And 3 times 5, right? So now let's look. I have 1, 3, 5, 15. This would be 3, this would be 5. The prime factorization here is 3 and 5. And notice we only have 1 3 and 1 5. If we're factoring 12, it's 1, 2, 3, 4, 6, and 12. And so this would be 2, 3, 2 times 2, 2 times 3, and then 2 times 2 times 3. So clearly anything that factors in here is not going to have more than 2 2's or more than 1 3. So far that is holding true. So I want you to notice that the number of times each factor occurs in the product is the sum of the number of times it occurs in each factor. So I can't have less 2's in the product in here than there are in one of the factors. So if 24 has 3 2's in it, it's prime factorization, right? Right here. I'll go back here. No factor of 24 can have more than 3 2's. So this 12 is a factor of 24 and it does not have more than 3 2's. 15 is not a factor, but we were just checking that out, right? Any factor of 24 has at most as many 2's and 3's as 24.